And welcome back to my channel. There is a question on chemistry calculation that says we should write the electronic configuration of the following elements. Element A has atomic number of 13 and that of B has atomic number of 22. So the first question says what block does each belong? Second question says to which group of the periodic table does each belong? And the last question say what are their periods? Okay, let's start. Solution. Now, first thing first, you need to recall our energy levels, right? If you have not seen the energy level that I drew the graph, you have to go back to other videos and watch it. But for now, I will proceed building on that previous knowledge. So A has atomic number of 13, and whenever you have atomic number of 13, the SPDF blocks or sub levels can be written for 13 as follows. So we'll be having 1x2. Recall that the highest energy S can carry is 2. The one that P can carry is 6. D can carry 10 and F can carry what? Up to 14 electrons. So we have 1x2. After 1s we go to 2x. After 2s we go to 3p. After 3p we go to 3s. Well, let's put the information first, the electrons, and see. Now the highest that s can carry is 2. The highest that p can carry is 6. So if we add up this, we have 2 plus 2, that's 4. 4 plus 6, that's 10, right? Now inside 13, that means we are left with only what? 3. But this S block can carry only what? 2. So we have to include the last 3p, which will then carry that 1. So if you add up everything here, it gives you what? 13. Okay, so this is the first thing to be done anyways. Then the second thing is what block. So if I call this one the option A, what block? So let's find the block in which this belongs. Now, how do you know the block? The block is the SPDF that we follow. So the last one is the one we are going to be taking. So based on this arrangement, the last block here is P. So this is P block element, right? So it's a P block element. Now let's go to option B. Option B says to which group of the periodic table does each belong? So for this, how do you get the group? Now, in getting the group, let's write the electronic configuration again. 1s2, 2s2, 3p6, 3s2, 3p1, right? So how do we get the group? Now, if you are drawing electronic configuration, this is the first, this is the second, and this will be the last, based on this atomic number. So if you remember your K, L, M, and N shell, right? So you discover that if we draw the cycle for this, the 2 electrons will carry the first shell, this 8 will carry the second, and these 3 will be at the last one. So these 3 outermost shells are where we get our group. So 2 plus 1 will give you what? The group now will be what? Group 3 element. So these are what? This is a what? Group 3 element. So let's go to option C. Option C say what are their periods? How do we get the periods? Now, in getting your periods, this is what you should consider in getting your period. Now, period is easily gotten from still the same electronic configuration, right? But how? This is very interesting. To get your period, now look at all the blocks, right? We have S here, We have P here, we have P here. But what are the energy levels? We have first energy level, second energy level, third. So we are going to be picking the highest energy level here. That will give us our what? Our period. So looking at this is 1, 2, 3. So the highest energy level here is 3, right? So how do we get our period again? We pick the highest energy level. So the highest energy level here is what? 3. So this is period 3. So this element belongs to what? Period 3. Now let's look for the next element. This element has atomic number what? 22. So let's draw out the electronic configuration of the element. Now we have 1x, 2x, 3p, 2p, 2p, sorry, I didn't do 2, 3s, 3p. Okay, let's put the values first. Let's see. Let's put the electrons. Here we can have 2 alone, 2 alone. For p, we can have up to 6. For s, we can have 2 again. For p, we can have up to 6. So let's count this first to know how many we're going to be adding up, right? So this plus this is 4, plus this is 10. 10 plus 8, that's going to give us 18. So we are looking for 4 extra, right? So the next energy level is 4x, and s can carry only 2. So we have to enter 3d down, the d block, so it will carry the remaining 2, right? So the d block will carry the remaining 2. All right, so if that is it, we'll count now and see. This is 2 plus 2, 4 plus this 10, 10 plus 2, 12, 12 plus 2, 18, 18 plus 2, 20, and 20 plus 2. That will give you what? 22. So we have gotten that for this element, the electronic configuration. Now option A says which block it is located. So based on blocks now, we just look for the last energy level, and this is what? The D block, right? So it's in the D block. So this element with atomic number 22 is in which block? The D block. The D block. So it's a D block what? Element. So this, sorry, this D is written in small letter, please. So it's a D block element. All right, option B. Now we're going to be looking for the group. So let's bring out the electronic configuration and divide it into the KLMN shells. So we have 1x2, 2x2, 2p6, 3x2, 3p6, 4x2, 3d2. So if we take this one for the first shell, second, third, and the last, right? So this is KLMN shell. So for the last shell, that's where we check for our group. And if you look at it, we only have 2 electrons here and 2 here. So 2 plus 2 will give you 4. So if you are looking for the group, it will now be what? Group. So this element is in group what? Group 4, right? Because we got it from these 2 and these 2 here. So we have group 4. Now the last but not the least, which is option C, we are looking for the period. So how do we know the period? The period is still checking for the highest energy level here. The highest energy level in this electronic configuration is 4. Is 4, right? So we are in what? Period 4. So it's a period 4 elements. And we know that period 4 elements are called transition elements, right? So it's a transition element. Okay, I'll wrap this up here, and then I'll hope to see you in other videos. Bye for now and take care of yourself.